We're going to solve this cute decimal to fraction problem from the 1986 Math Counts competition. We want to write 0.36 repeating minus 0.36 as a common fraction. Now, it doesn't seem too tricky, right? We just got to write this as a fraction, then write that as a fraction, and then subtract them. The difficulty comes in with the repeating decimal, 0.36 repeating. How do we write that as a fraction? Well, give it a try yourself. My hint to you, which may or may not be helpful, would be to consider the common algebraic proof that 0.9 repeating equals 1. And you can use that same sort of strategy here to clean up the repeating decimals. I know some of you get a little excited when the topic of 0.9 repeating comes up, so try to behave in the comments. Grab a cup of coffee and let's solve this problem.
Coffee time now with your host, Wrath of Math.
I've got my Poland Springs dark roast here, so let's get into it. Now, we could take the approach of turning this into a fraction, then this into a fraction, and then performing the subtraction. However, since the first two non-zero digits here are the same as the first two non-zero digits over here, it'll actually work out pretty nicely if we just do the subtraction now and then turn that into a simple fraction. So what do we get if we subtract 0.36 from 0.36 repeating? Well, nothing's going to change except the first 3/10 and the 6/100. Those will be canceled out by the 0.36 that we're subtracting. And so this will be equal to 0.00. We've got those first two zeros. And then after that, the 3 6s just go on repeating as before. Now, how about this? Let's say that this is x, this difference, 0.0036 repeating. So x equals 0.0036 repeating. Oftentimes in mathematics, it's helpful to just give something a name. Let's go ahead and multiply both sides of this equation by 100. If we do that, we get that 100x is equal to, well, this decimal point is just going to hop over 2 places to the right, so that would be equal to 0.36 repeating. Same thing we had up top. All right, let's subtract the top equation from the bottom equation. That's going to be 100x minus 1x, so 99x is equal to 0.36 repeating minus 0.0036 repeating. Well, that's actually going to get rid of all of the 3 6s except for the first two, since we've got those zeros there. So this will just be equal to 0.36. All right, seems like we're getting warmer now. Let's multiply both sides of this equation by 100 again so that we've got a whole number here on the right. If we do that, we'll have 99x times 100, which is 9,900x. On the right, 0.36 times 100 becomes 36. So all we've got left to do now is write x as a simple fraction. We've just got to reduce 36 over 9,900. So dividing both sides of this equation by 9,900, we see x is equal to 36 divided by 9,900. Let's simplify. Do you see a common factor between 36 and 9,900? Obvious one that jumps out to me is 9. 9 goes into 36 4 times, and 9 goes into 9,900 1,100 times. And look at this. 4 pretty obviously goes into this numerator and this denominator, so we can finish simplifying. 4 goes into 4 just once in the denominator. My chalk broke. How many times does 4 go into 1,100? Well, 4 goes into 1,000 250 times. 4 goes into 100 25 times. So 4 goes into 1,100 275 times. And so we have that 0.36 repeating minus 0.36 written as a common fraction is 1 over 275. And that's it.
Subscribe for more of the swankiest math videos on the internet.